you really are now. I'll be so good. I wish I could get the message over to you now.
Good. Okay, folks. Could we get some people to volunteer to take notes instead of doing your own email? Well, ask nicely now. Then we'll start designating victims and volunteers.
You have blue sheets somewhere.
Blue sheets will be in that binder. If you can set them up on that, that'd be great.
We have two lots of blue sheets.
That's what usually happens. Oh no, we have two sessions. We don't need the second set because we're just gonna do this back.
We could just hand this one round again, I guess.
Yeah. All right, who should we ask? Who should I go bug personally to take notes? All right.
Pen with it? There's no. Okay, sorry.
Paul Condon. Okay. There we go. Okay. We also need a Jabber scribe. Who's in the Jabber room? Is anybody in the Jabber room? Could somebody get into the Jabber room?
I'll try, David.
Okay, let me go get the door here. Okay. Have note takers. Want to thank Richard Scheffenegger and Paul Congdon. Gory is going to try to stay on top of Jabber from up front here. Welcome back to the three ring circus, better known as the Transport Area Working Group. I'm David Black, one of your chairs,
And I'm Gory Fairhurst, the other chair present.
and Wes is chair in absentia. Okay, this is the new and improved note well, complete with BCP numbers. This applies to everything that goes on this meeting. You're expected to be aware of it. Okay, we have a couple of note takers. We have Jabber session scribes. We will be soliciting as we go along reviewers for various drafts that come up in the meeting. Reminder: please use TSVWG as the as part of the draft name. Draft your name TSVWG and that way the chairs will notice it when we're trying to figure out what's going on. Reminder: document quality relies on reviews, so please review documents in your working group and here, and at least one of the documents in another working group. If you like documents you care about reviewed, please return the favor and review other people's documents. They may review yours. Okay, on to concert status. I think at one point I saw a slide from Spencer only had 2 RFCs on it. I found 2 more. Carefully setting the search date to the beginning of the Singapore IETF meeting week, we've had 4 RFCs published since I last put a set of slides like this together. The best of them are the first 2, which are a couple of SCTP RFCs that are part of the massive WebRTC draft hairball or tarball, if you like. We managed to extract those 2 out. The really, really good news is, thanks to diligent efforts of a number of people in the room, we are no longer on the critical path to getting WebRTC done. Thank you very much, everybody. We still got 1 draft that's stuck against some other WebRTC drafts, but WebRTC will sort that out. 2 more, ECN experimentation draft and the DiffServ to Wi-Fi mapping draft. The draft bottom of the screen is the remaining draft that's stuck in the WebRTC hairball. Okay. So Spencer, right now you get it easy. You have no IDs that are with you or the IESG. We're about to change that. SCTP errata and issues. I believe that's going to be submitted. Publication press. That's going to go in soon.
I believe so.
Okay. We have an ID in working group last call, ends March 30th. DSCP IANA process changes. This is needed for the DiffServ lower effort PHB draft that we're going to talk about later in the session. I think I heard something Spencer said something like tidal wave earlier. We are about to send 5 internet drafts working group last call. Hope to do last call on all of these before Montreal. The good news is they only come in 3 batches. After we get the DSCP IANA draft dealt with, we're going to we expect to working group last call the DiffServ lower effort PHB draft. The ECN drafts on encapsulation for low layer protocols and tunnels use shim headers will be last call together. I believe those are about ready for last call. And in addition, the 2 FEC update drafts are also expected to be ready for working group last call, and we expect to working group last call those before Montreal. So there are another 7 additional working group drafts that we'll talk about. SCP NAT draft, 3 drafts on the L4S low latency service, UDP options draft, tunnel congestion feedback, and datagram datagram packetization layer PMTU discovery, which is a recently adopted draft. A couple of slides on related drafts. There are 2 drafts that you will see on today's agenda. One is transport header encryption impact, which is Gory's draft, and the other is priority switching scheduler draft FinZ. Let me say a word about what we're going to do with that. There's been some offline discussion, and it appears the best route for that draft is publication as an independent submission. However, when the draft is presented, we're going to be asking for reviewers, because what we'd like to do is, in essence, empower the draft authors to send it off to the independent submission editor with a stamp of approval from TSVWG that says we've looked at it and we think this is a good thing for the independent submission editor to publish. So that's what's going to happen a little later in this session. 3 more drafts not on today's agenda. Generic multiplexing draft, draft Saldana. Tom Herbert has a new draft on firewall and service tickets, which is trying to do things in band. And I'm looking at Tom and assuming he's going to sort out how this relates to all the work going on in the I2NSF working group. Congestion control for guaranteed bandwidth. This draft actually turned out to be a TCPM related draft, but I left it here because they put TSVWG in its title. There was some discussion of this in TCPM on Monday, and there's been quite a bit of list discussion. Over in INT area, there's 3 more drafts that are relevant to us. Tunnel MTU considerations. There's actually a whole draft on tunnels in the internet architecture in INT area. Fragmentation fragility. That's also a draft in INT area, and SOX version 6. All of these drafts are being handled by the INT area working group. Okay, so you're now in the middle of chair slides. We're going to be bashing the agenda a little bit. We've done the note well. Just went through document accomplishments and status. So what comes next is milestones review. We have a few milestones that have gone past, but we're close. The RFC 4960 errata and issues draft should be submitted to the IESG in the next week or 2. The other 2 orange drafts up here are the 2 ECN and CAP drafts. Those we're going to move the dates out to June 2018. Both drafts have new versions. Bob, both have new versions or just 6040? Both have new versions. Both are believed to be very close to ready for working group last call. Our intent is not to have these milestones show up again in Montreal. The lower effort per hop behavior draft, we're going to try to work group last call this very shortly after we get done with the DFCP IANA draft. SCTP NAT support. Michael, what's a good guesstimate date for that?
Have a document ready for working group last call by the Montreal meeting, and address the stuff after that, and then it's ready.
Okay, we'll propose a suitable milestone for that then.
Yeah, I think October is a good. October does in fact look like good milestone. Thank you. Next 2 milestones are the 2 FEC framework draft. Vincent and team are on schedule for those, so we expect to be working last calling those from Montreal. The L4S drafts currently have a September date on them. During the L4S session, we can discuss likely timing for those. And then there's a December date on the remaining drafts. And as we get to Montreal, we'll try to figure out what's going to get done this year and what's going to have new dates into new dates into next year. Okay, a little bit on the agenda. So we've done document status chart and accomplishments. This is agenda bashing, and I'm going to use this opportunity to say a few words about the tunnel congestion feedback draft. Right now, this draft is currently sort of stuck. I think we had a discussion with our ADs about this draft back in Prague, and the determination at that point was a mechanism without a worked example of its usage doesn't get as much of anywhere. And with luck, Bob is going to the mic to tell us that there's a worked example of its usage about to emerge.
Always, if you were just going to say that, I don't need to, but.
Why don't you go ahead and say it
okay.
that way? I'm not trying to repeat your words for you.
Okay. Donald Eastlake, I happened to be talking to him in the service function chaining working group. Wants to use this with Andy Malice for doing load balancing essentially across service functions. And I pointed to him at that draft, and so he's willing to jump in and help those guys finish it.
and they figure out how to do it. The banana draft, I notice, it seems to be trying to do that and is not particularly clued into how to do it. Might have something to work from. That would be very good. What I was referring to is the banana drafts, which are inter-area stuff, are some individual submissions, and there's a banana draft and ECN that is also trying to use what is effectively tunnel congestion feedback to do load balancing. Okay. Right after I get done with this wonderful monologue, we're going to do the lower effort PHB draft, which will be Gory and Roland. We have the presentation on priority switching scheduler, which is exposes material. Folks, take a look, because we're going to be looking for people to please help review this draft. We have the packetization layer PathMT discovery draft, the two ECN cap drafts, LFRS drafts, and then there is some new activity that's been proposed over in IEEE 802.1 called congestion isolation. Paul Connor's going to talk about. That should get us to the break. We may pick up the FEC frame drafts before the break if we do well on time. That would be an item for the Journal of Irreproducible Results. FEC frame drafts. I'm not sure why we put an asterisk on that.
I put an asterisk because I thought it may appear before the break.
Okay. UDP options draft, which I think, let's see, we've got actually two presentations on that. We've got actually an actual implementation report, and then who's going to be trying to do a formatation of Joe Touch?
I'm going to try and be Joe Touch. He sent me some slides, and I think I know what they're about.
Couple of SCTP drafts, which I think is going to be fairly quick. And then if you were at the plenary last night, you heard a little bit of discussion about sort of the overall impact encryption on the internet. We have a draft on transport header encryption. And I think that's it.
Anybody got any questions on the agenda or anything that we may have missed?
Anybody want to bash the agenda? All right, consider it bashed. Okay, DSCP registry. Do you actually need slides, or do you just want to talk to it? Okay.
Give me some slides.
Let's see if I can find you some slides here. Ah, there it is.
Yeah.
Hang on.
This is really cool because they're going from the chair's mic to the floor mic is just like 2 steps. So this is Gory Fairhurst speaking as an individual on a working group draft. And the working group draft's got the rather implausibly long name, well, there's only 3 sides, of IANA assignment of DSCP pool 3, one values to require publication of a standards track or best current practice RFC. If my AD wants to bash the name, he can do. I don't care. This is a photo of Balmoral because it's close to Aberdeen. This is the purpose. Oh, he wants to try and bash the name already. Okay, here we go.
The Spencer Dawkins speaking his responsibility. Was I supposed to be offended that the name is meaningful?
No,
it's really okay. It's really okay.
It's good. I thought I would do the draft in the name. Yeah.
I thought there was everything in there but my name.
Okay.
Roland Bless, I made the suggestion just to replace the last part by require standards action, which is a little bit shorter but has the same meaning.
Okay. Seriously, we might update the name before we finish it.
And which castle did you use?
That's Balmoral. That's where we are. And the overview of the draft is it simply changes this pool in the IANA registry, which already exists, from being a local use registry to being a standards action registry. And we believe that there are no bad effects of doing this, but we're the IETF, so we write a document to make sure everyone else believes that there are no bad effects of doing this. That's the purpose of the document. Apologies if you read the last version, the 00 version. It had everything talking about Iona, this is this picture of Iona in Scotland as well, not IANA. My spell checker had a wonderful time over the draft, and I was submitting it very quickly. And don't read that version, read 01. And seriously, because it's only one registry item we're changing, I think this is now ready for any comments you may have. It's in working group last call. Thanks to people who've already sent me comments. I know of 1 or 2 changes I do have to make, so I will include those in the final version. I've already fixed one typo. I realize there's a may with a capital M and but small a's and y's, and I realize there's some inconsistency with the ANA registry in terms of the placement of the ordering of some of these things. Anyone got any other comments? Please tell me.
Yeah, Roland Bless KIT. I think I already sent some comments on the 01 version.
Yes, you have.
And yeah, okay, so you've seen them. Okay, so
and they're fine.
Okay, good.
I'll do that.
Hi, Bob Briscoe. Sorry, I got distracted. I came to the mic to ask, when you say that you don't think there'll be any negative consequences of doing this, how do you know, given they were local use and now they're not?
I said that because I have to assert that to be able to put this for publication request. Yeah, we have talked about this in previous meetings, and the reason for presenting this here is to try and make sure of that. When we go to IETF last call, we will make sure that we also tell other working groups, heads up, look, there is a change here. We don't think it's bad, but there is a change.
If any of these are in use for local use, the domains in which they are using them should be doing edge policing that will catch and correct whatever's going on. Well, catch. I don't know about correct, but at least catch.
Spencer Dawkins, David answered the question that I was going to ask, so let me ask my next question, which is, if those networks are using the local use DHCPs now, don't they have to explicitly shoot themselves in the foot to start having problems?
They shouldn't have problems if they do what DiffServ says.
Yeah, I mean, so you look at this and say, we're using pool 3 now, and we should not use pool 3. I mean, is this hard?
DiffServ asserts that it behaves best when you have completely perfect configuration of the network perimeter. Now, a network with a completely correct configuration of its perimeter is on the same category as Santa Claus, the Easter Bunny, and the Tooth Fairy. But I don't think there's going to be there are going to be major problems, and a network that is using these as local use will have the ability to reconfigure to some of the other local use code points, the 1.1s.
I look forward to the Shepherd write-up with great glee.
I think he looked at me when he said that.
I think it's not such a big problem because there has been the warning sign on the declaration of pool 3 that it may be later on reused for standards action. So if
we did do that.
Was a provider, then basically I would use rather pool 2 in order to avoid renumbering later. So the only case is if a provider uses, let's say, lots of local code points and now has not enough code points left. But I mean, yeah, right now we're starting to use 1 for standards action. So yeah, so local remapping is always possible.
My summary is still basically that when this completes working group last call, we're going to do a write-up and we're going to make sure we have feedback from everyone in the IETF. It's much more important that this is well known before it's published than when it's published. So the purpose of this document is to tell everyone in the IETF that it's happening, and then IANA finally to make the change. And that's my slides, David.
Okay.
Thanks. Yeah, Roland Bless from KIT. Just what happened to the lower effort per behavior draft? Lately, there were some changes. One major change was to fix the code point to no 1. And I also added the reference to the presented draft from Gory, and now the working group draft, in order to open pool 3 for a standards action. Several editorial changes, so not really much new here. I actually added updates also to the recently published mapping diffserv to 802.11 RFC. And yeah, I think there's one more draft or RFC to be updated, but I'll come to that later. So review comments, Rüdiger Geib sent some comments in, mainly editorial, so I'll try to maybe shorten some phrases as suggested.
Roland, before you go to Bob's comments, could you go back to the previous slide and let me do a real quick quasi-administrative item? Want to make sure that we can report that the sense of the room is that the first bullet is what we want to do. We've had long discussions about that, and I think it came down to code points 1 or 5, and there's some data that I think Brian Trammell sent to the list that suggests that, as we suspected, 1 is probably the better choice. So are there any objection to use of 1 as the recommended default code point for the lower effort PHP? Hearing and seeing none, I will record that as a sense of the room in London. Thank you. Okay.
Okay, and then there was a suggestion of from Bob Briscoe about the use of lower than best effort congestion control. So formally, I had these two different semantics. One is LE user suggests lower effort PHP use, but doesn't care if traffic gets treated better on the path. And the other, that would be LE minimum or LE min semantic. And then the other one is the LE strict semantic, so that the LE user wants to ensure that there's no harm done to the best effort traffic aggregate, and then even if some remarking happens. And then the suggestion was to use lower than best effort congestion control. So I just sent an email to the list that I will try to clarify on that. So my proposal is to write LE users should use a lower than best effort congestion control because blah, blah, blah. And then also what happens if you don't do that, right? So implications of, maybe negative, or if you don't use such kind of congestion control, then you can expect some problems. Comments to that?
Bob Briscoe. I just wanted to try and explain in face-to-face what I was trying to say, and that is that at the moment the text essentially says, if you don't want to harm people, you shouldn't harm people. Right? And the condition shouldn't be what you want to do or what the application wants to do. It should be whether there will be harm. You know, so it's about if the traffic is unlikely to harm anyone, then you don't need to do an LBE congestion control. But otherwise, you do. It's not about whether you want to harm people, because that's just saying psychopaths are okay, and psychopaths are going to do it anyway. You know?
Yeah. Okay. Sure. Yeah.
Well, you've got Gory to the head of the floor, Mike, and you may have me headed there shortly thereafter.
Oh, okay. So Gory Fairhurst from the floor mic. Yeah, I much prefer a approach that says should use a lead-bath style, less than TCP type congestion control if you're using the LE class. Should be, don't have to. If you don't, then there are going to be interactions between an application that uses multiple classes, and there may be interaction with other traffic. And if we explain that more clearly in the wording, then I think that's much better guidance than simply kind of waving our hands. I'm a little bit scared as an individual about the use of must do something when we can't actually force anyone to do it, and it's not clear how you check that interaction. But I do like the idea of saying should and really meaning should, and then explaining what the ramifications are, and then people can make an intelligent decision.
Oh, great. So is really, really should going to show up in one of our April Fool's RFCs?
All right.
Chairs running around.
Yes, we've now done the chair exchange. This is David from the floor, Mike. And what I was going to observe is that from an operator point of view, should versus must is kind of irrelevant, as the operator is going to have to defend against this regardless of which word we put into the RFCs. And I'm inclined to agree with Gory that a should is appropriate because I don't think anything changes in what the network's going to have to do if we put a must in. Bob was saying something to the effect, but it's not about the should or the must, but what?
My point wasn't about a should or a must. I don't care about the should or, well, I do a bit, but it's more about, it just doesn't make sense saying that if you don't want to do harm, then use an LBE, because if you don't want to do harm, you will use an LBE. It's about whether you're going to do harm.
Well, and and I think we need to take a closer look at the wording, because the real concern for the network is not whether a flow does harm; it's whether the flow is using this in aggregate would do harm. And that's a little bit different, and not something an end user always has enough visibility into.
Let me explain where I'm coming from. I have in mind, I'm thinking about L4S, and I'm writing mappings for diffserv for L4S at the moment. You can do a really good less than best effort congestion control with a scalable congestion control because it jumps up really fast. But I don't want anything that doesn't have an LBE in the L4S queue because it will screw the latency. And so, it affects that. But I mean, that's a special case maybe, but it's from the network operator's point of view, if you've got an RFC that says, well, you can or you can't, it doesn't matter whether it does some harm or not, that means you can't say we should put this traffic in here or we shouldn't,
So Gory is back at the chair mic, and what I say, Bob, is that sounds interesting. Would you like to send some sentences to the list to help us frame this? I mean, I think some good examples here would make the should actually meaningful.
Yeah, and I think an operator's perspective also needs to be added. I promise. Look at the text Bob sends and add some more text.
Thank you, David.
Yep.
Roland, does that help? Do you
I
have
think
a particular
so,
request for any text, or are we just going to do it on the mailing list?
No, mailing list is fine. Yeah, so maybe we can discuss this on mailing list. I checked the PHP guidelines from RC 2475, and I just came across the G7, guideline 7, which talks about tunneling. I don't know whether we have to state any extra text about tunneling. I don't know. I'm not a tunneling expert. I know, David, you did the tunneling diffserv draft.
Taking off chair hat and putting on RFC 2983 hat, I think a reference to RFC 2983 will suffice. I'm going to jump ahead and say, and I would recommend recommend not spending a lot of time on on
Yep.
G15, among other things, because if we look at the Wi-Fi draft, which we just put out as an RFC, it's pretty clear where to map this one on Wi-Fi.
Okay, good. So, yeah, one thing I overlooked is actually the RTC Web QoS draft, right? That also needs updating then. So I should
because
add
it
that.
mentions CS1.
Yeah, right.
It does.
I mentioned CS1. So I overlooked that. Sorry for that. So I will also update that in version 05.
Spencer, we're about to update a draft in the RFC editor queue. What's the mechanics you want used to do this?
That's good.
I think the RFC number is already assigned then.
Well, it does, just ask Spencer.
I'm quoting Adrian Farrell, so I don't have IPR on this. How do you expect me to get email read if you keep interrupting me?
And I remind you that Adrian
could you
did that when I asked her a rather blunt question about something at the back of the room.
I thought I understood what you were saying, but just to make sure I'm answering a question that was at least somewhat asked, could you take a swing at it again?
Okay, the document refers to CS1 as the background class code point. This now is being updated to this code point for LE traffic. So there's actually a change to the recommended DSCP.
Right. So in particular, the process question to you is that the RTC Web QoS draft is languishing in the RFC editor queue because of the RTC Web hairball, and this draft is going to need to make an update to that draft.
So for any normal, Spencer Dawkins, for any normal draft, I would be happy to handle stuff in Auth 48, but I'm not sure that I'm not sure that all the authors will be living when the hairball is published, which makes it less likely that that's going to be effective. I'm happy to drop a note to the RFC editor now. If you would send me what I need to tell them, I'm happy to do that, and let them do the things that they do.
You just answered the questions. I'll fill in the rest of the blanks, which is that at the conclusion of, I think, IETF last call, we arranged to tell the RFC editor what changes are needed to the RTC Web QoS draft, and the RFC editor will dutifully make them.
Copy me, but yes, thank you.
With AD approval. Thank you.
We probably should let the RTC Web people know now that we've decided the code point pretty soon, because we shouldn't change the document that they think they've been referring to. So we will let other people know of the consensus this IETF finally confirmed about which code point it is, and they will then be aware of this upcoming change. So we can handle that bit.
And actually, if you CC the mailing list for TSVWG, then that will cross every, that will dot every I on the process that anybody could say, but did you? And actually, you don't have to copy me because, hey, I'm on the mailing list. Thank you.
I suspect we start with Fluffy to figure out all the places that need to know that we have now made a decision.
Okay, we can do this.
So basically, I'm done then. Right.
Okay. No. All right.
Finzi next. So this is a talk that didn't happen in Singapore for no reason that was important. Now we have a chance to hear from Finzi.
Right, and quick reminder: the destination of this draft is publication by the independent submission editor. And the goal of this is for people to understand this draft. We're going to be soliciting a few reviewers because we'd like to be able to say that TSVWG thinks that publication of this draft as independent submission is a good idea. So, Anae, is that how I'm supposed to pronounce your name?
Sorry?
Your first name, Anae?
Anaïs.
Anae.
Okay. Good afternoon. I'm going to talk about our priority switching scheduler. So sharing the capacity of a link is an important issue for mixed traffic, as you all know. And there are many existing solutions, like waiting for queuing, or deficit round robin, and so on. but they are complex to configure and they provide only soft guarantees. And so our objective with this new priority scheduling switching scheduler is to achieve a service closer to PGPS and obtain a more predictable available capacities. So, in fact, we want to ensure a more predictable output rate. So we have a use case to show how we want to use it as an example. So the idea is to make the AF class more predictable on a DiffServ core router architecture. Just as a teaser here, I have shown the two figures with the range of the AF output rate as a function of the EF input rate when you vary the rate scheduler weight. So here you can see that the range is larger with the output with the rate scheduler compared to our scheduler weight. Compared to our proposal. I will go into more details in the following slides. So in our draft, we have an introduction with the context and motivation, and a first explanation of the priority switching scheduler. Then we go into more detail with the specification and the implementation. Next, the use case I just talked about, showing the benefit of using PSS in a DiffServ core network. And finally, the security considerations are still a work in progress. So PSS in a nutshell. The PSS is based on the burst limiting shaper, and the key idea is to use a credit counter to change the priority viewed by a priority scheduler. So you have non-active PSS queues, which are regular priority scheduler queues, and other queues with an active PSS. The idea is to update the credit counter according to the output of the priority scheduler. In turn, it allows the selection of a priority, which can be the low priority or a high priority. And this priority is set as a priority viewed by the priority scheduler. So that's the key idea. As you can see, there are two things to establish. It's how does the credit change and how to select the priority we use. So we have 3 parameters per control queue. We have a max level for the credit, a resume level, and a reserve bandwidth, which is used to compute the credit slops. I will explain more how it works. So here is an example. As the x-axis, you have the time, and as the y-axis, the credit of the control queue we are looking into. We are transmitting several packets here, and when we are transmitting packets from the control queue, we are increasing the credit with a rate I cent. When the credit reaches the level max, we change the priority from the high priority to the low priority. And due to the fact we are using a non-preemptive static scheduler, there is some non-preemption leading to the saturation of the credit at the maximum level. Then we send other types of traffic. So we decrease the credit with a rate idle. When the credit reaches the resume level, the priority is switched back to the high priority. And again, due to non-preemption, we keep decreasing the credit until we reach zero. The credit reaches 0, or until the end of the transmission of the packet. So this is an example that is true, but I think it's a bit misleading. I think it's the best way to explain it first, but a bit misleading because it may give you the impression that when the priority is high, then we only send the control traffic, and when the priority is low, you only can send other traffics. So I have another example. Here we start by sending a few packets, and so we increase the rate with I send. Then, for some reason, either because the other traffic has a higher priority or because there are no more control traffic in queue, then we can send other types of traffic. So we decrease the credit with the rate idle. Then maybe we can again send the control traffic, so again the credit increases. Then if all the queues are empty, the credit decreases. Then again we can send credit, and so eventually we can reach, the credit can reach the level max. So we have again the change of priority to the low priority, and so we can continue with sending other type of traffics. And if all the queues with higher priority are empty, then we can send the control traffic even though the priority is low. And finally, the last example is if all the queues again are empty, the credit decreases. So you can see that we have a fairly simple scheduler, but with a quite complex behavior. So I think, I hope I have convinced you that it's an interesting scheduler, but here is a use case to emphasize it. So we want to use, we used the current core router architecture, which I think you all know. And here is what we usually obtain with such an architecture. Here on the y-axis is the weight of the AF class, and on the x-axis is the weight, and on the y-axis is the output rate. So the aim is to make the AF class more predictable. So we first study how it works with the current architecture. Let's say you know that the input rate of the EF class is around 50%, and it varies from 25 to 75. Then, as you know, the output rate will also vary. Here, for example, if you set the weight at 0.5, the output rate will vary between 12.5 to 37.5. So it's quite large, and we can conclude that the AF output rate is uncertain when the EF input rate is unknown. Our goal is to make the rate of the AF class more predictable. Our proposal here is to add the PSS and to use it to change the priority of the AF class. So the EF class still has the first priority, so no change here. And the AF class sometimes has a higher priority than the default class, sometimes a lower priority than the default class. And as a result, we obtain a more of, this adds fairness to the priority scheduler. Through simulations, we have obtained these curves. So we set the parameters to obtain the same red line as before. Here, it's the same. And what we obtain is that for an input rate of the EF class below 50%, we obtain the red lines, which is very good. And then when we increase, if we still increase the EF input rate, we obtain the minimum between the remaining capacity and our red line. So here at 75%, the remaining capacity is 25. So if we compare both scheduler, we obtain a much larger area of uncertainty with the rate scheduler compared to our proposal PSS. And what is interesting is that if we want to provide a minimum guarantee for the AF rate, output rate, with a rate scheduler, we have to set the weight at 0.5 to obtain 12% output rate. But with our proposal, we have only to set it at 0.5%, meaning we have 0.75% that can be given to other priorities if needed. So to conclude on this use case, the EF class is not impacted by the change. I think it's important. When we know the EF input rate, we can have easily the same behavior with PSS and with the weight and round robin. When the EF input rate varies, that is where our PSS has a better behavior because the AF output rate is much more predictable. And these results have been corroborated with the simulations on NS2. To sum up, the PSS provides a better predictability for the capacity available to control queues, and it's hardware implementable. It can replace any kind of round-robin scheduler, and we have an ongoing implementation and interest from satellite companies to test this proposal. Thank you.
Questions?
Roland Best, KIT, thanks for the presentation. Could you go back one slide, please? Yeah. You say EF class not impacted by the proposed change. I'm not quite sure how you come to that conclusion. So the EF definition has some notion of error term. Did you look at that? Does it get worse?
We didn't see. We ran the simulations and we didn't see any notable changes. And even if you look at it, here you see the EF class is at the first priority, and it's exactly the same with our PSS. So the maximum impact is only the maximum frame size of a lower capacity of priority, so only EF and D, that doesn't change.
Okay, maybe I have to check the paper. Okay, thanks.
Okay, now we need a few reviewers for this. Roland, if you're going to go look into this, would you be willing to write up a review of this? Oh yeah, no good deed goes unpunished.
This is Rüdiger Geib, Deutsche Telekom. I think to understand that your proposal would remove the requirement of a Polisa from an EF class, which is very good. If this is true, I didn't read the draft. The other question is, does this require any new work on a PHB by IETF? So would this content in some relation with RFC 3246?
Not sure. It can replace RED's scheduler.
Okay. That's what I understood. Because so far IETF did not specify any schedulers. And I think the original DiffServ workgroup refrained from that, from specifying schedulers.
Yes, they give several alternatives.
Right. And one of the...
Sure. And if we don't have to change it, my question would be whether we need standardization work on this.
Misintroduction. This is not going to be published as a standard. This is going to be an independent submission. We're looking to provide some reviews so that we can give the authors effectively a note to send the independent submission editor that says TSVWG thinks it's a fine thing to publish. It's good work.
Great.
Okay. Would you be interested in reviewing the draft? I get my reviewers.
I'm not an expert on all that.
You don't need to be.
Scheduler disciplines. I appreciate the work and I understand what it's good for. To be honest, I think I'm not sure whether I like to entertain so many classes on a 100 gigabit trunk. That would be my honest response.
And your operator's perspective on applicability would be quite useful, quite interesting part of the review.
I think about it.
Okay.
Thank you.
I got one more question. You said it's easy to configure. You had some slide, I don't remember the number, where you had parameters. Yeah, I think then, yes, this one. So do you need to set these 3 parameters?
Yes, but in the paper, well, in our paper, we propose a way to translate the current weight toward these 3 parameters. Okay. So that's why it's easy. You can use the current configuration and easily get those three parameters.
Corresponding set
Yes.
of parameters. Okay, thanks.
And you can even simplify a bit by removing the resume level. You can use 0 if you want. It's a bit of a simplification. It's maybe not optimum, but it's a simplification.
Yeah. So thank you for your talk. This document won't go for a working group last call, so please review it. If you have any interest, send comments, please, to the authors. That doesn't have to be a full review. Any comments will be welcome. Next up, Tom, and also blue sheets. If anyone hasn't completed this, please indicate to me.
Hang on, let me go clean out my view full screen, and that should be a clicker.
Oh, I can't see that. Hello, Tom Jones. I'm going to give an update on our draft packetization layer path MG discovery for diagram transports. So since this was last presented in Singapore, there have been several updates. The draft's been adopted. We have taken some implementation experience and we have updated our state machine as we've renamed some states and we've added a new state for UDP transports. We've added text for considering search algorithms based on discussion from the list. And probably the most important thing there is providing useful growth as you are still searching so we can feed that forward. We've added text on Quick. We think Quick can support everything we need in the draft, but that was Quick last week, not necessarily Quick this week. We weren't expecting them to try and get rid of pings. And we've also added text on path2big handling and other mechanisms where we can signal path2big style messages. So in Singapore, the state machine looked like this. And just a quick overview. We enter through in probe non. We have this for unconnected transports. And then we validate connectivity, move it to probe base. In probe base, we need to validate that a base MTU is going to work. And once we do that, we can then move into a search state. And then from there, we can perform a search. And we search up until we hit a maximum MTU. And then we are done. And then we can settle down. So what we've changed is we have renamed the initial state from probe non to probe start to better reflect where we are. We've also added a timer mechanism so we can figure out if we can actually establish connectivity. And then one thing that's probably still missing from this is in the probe search state, we need a pointer out so that we can incorporate different search algorithms. Currently, we have 2 in-progress implementations. There is an SCTP patch set against the algorithm as it was in the initial 0.0 draft. And we have a UDP options-based implementation, which is very close to being something that we can test in real networks. Okay, so we have some questions for the working group on path2big signals and what we should do with them. We know we need to validate these signals when they enter our stack, but what is the full validation procedure? We know we need to at least rebuild the 5 tuple so we know it's homing to the right connection. And we're pretty sure that the implementations we have, we cannot not do this. But we also have questions about how we consider the path2 signals we receive and what we should do with the new information we get from the network. We probably do need to probe to validate the new signal we have, but we don't know if this is where we cut off or if we just take this as a hint to incorporate in the search algorithm.
Quick comment on this one. I don't have any good answers for you, but I have a place to dig. in the slides that started the meeting, you saw a reference to draft Bonica int area frag fragile. Take a look at that. That will probably tell you a little bit more about PTB signals. Thank you.
I think they took our text, but we talked to Ron Bonica.
Mm-hmm. Good.
Michael Tuxen, can you go? Yeah. So at least for SCTP, we can do a verification, and we do this based on the verification tag. So it's not just a pipe tuple, but we have something in a blind attacker would have to guess. And I think we have to validate the packet to big messages, because this can just come from a box in the middle. So you only know you can reach. It gives you an upper limit, so you have to probe it.
Yeah, so you do have to verify it.
Yep.
Matt Mathis, author of the original packetization layer path MTU discovery RFC. If I can get all those words out. I didn't catch this on my horizon soon enough to have read it. I'm sorry. I do intend to do that. The issue of authenticating messages from the network to the end system, of course, is much broader than just this problem. And it would be good to revisit whether or not there might be some new solutions there or some more work there. In absence of that work, I would strongly recommend considering it just advisory. For one thing, we did run into bugs, people that returned things like byte swapped lengths in the advisory message. And so you have to be able to tolerate those cases.
Okay.
So Matt, can I ask as an author, because I can't run down to the mic quick enough, but are you saying that some path to big messages advertise MTUs which are just totally small when they're not really?
I don't remember specifically seeing what the failures were.
Yeah.
There's obviously in principle a denial of service attack to set somebody's MTU down to 2 bytes and make them dribble along. There's always, I believe the other draft admitted the possibility of just completely ignoring ICMP messages.
Yeah. And we have that in this draft as well.
You have that in this draft. And we did definitely see cases where they were byte swapped.
Yeah, there definitely needs to be a sensibility filter on the signals you get.
Yeah. I don't remember other cases. The other thing, this may not be evident from reading the other document, but our intent all along had been to facilitate jumbo discovery. Mm-hmm. And it turns out that after putting all that work into the draft, what it really did was move the problem down a level, because the NICs need to do buffer carving before they can talk to the switch to ask the switch what MTU it can just do. And by the time you've buffer carved the NIC, it's too expensive to restart it. And so it never attained that goal. So that was I'll say an off-topic agenda that we didn't adequately vet, or it was our motivation for doing all that work, but it didn't pan out.
Thanks for the author of reviewing this. Send us comments, please.
Yes, Magnus Westerlund. I mean, these verifications, I think it's very important to make it very robust, especially against at both attacks and these strangeness that just might happen. So, I'm working on a review on the document. So,
thank you.
Good.
Michael Tuxen, just one comment regarding making this validation more robust. For SCTP, there was at least one middle box in my house, which gave me, after the port numbers, a 4-byte random number instead of the verification tag itself. So I don't know how to make this robust, except for accepting anything which doesn't have this. So now it's fixed, but it took a year or two.
So Michael, you have a box in your house which gives you the wrong verification.
I had a box. It was fixed, but it took 1 or 2 years.
Eric Nakamai. After looking at this, like this class of issue for a bunch, or thinking about it, I think, and running into a wide range of issues over the past few years, I think one thing I've come to is thinking of PTB as a nice optimization rather than a must-have. And but I think one thing that, in order to make it useful as an optimization, that's worth really calling out and thinking about, and we started discussion on quick on this, is how does it interact with load balancers? Because oftentimes routing it back to in server clustered environments, how do you get that back to the right server is an interesting challenge. There's a few different approaches that may be worth calling out or pointing people to. But certainly on the validation side, I've seen both. I've both seen NATs that do interesting things to PTB messages, causing them to not be useful anymore or not rewrite them properly, as well as at least one TCP optimizer that did creative things as it was passing back the PTB message.
So two bits of feedback immediately from me on those two. I mean, Tom might also comment, but the first thing is, please tell us about strange path too big messages, because it might help us verify things correctly. If you want to send us an email, anybody who's seen a really strange path too big message relating to this, it would be really helpful input. The second thing is, I think the load balancing thing was one of the motivations for starting this in the first place. So we'd really like to get that bit right.
Yeah, and just on top of that, we refer to these now as path too big signals, but we do see the opportunity to signal from an upper layer that you do know something about the path. There's a new version of Evernote available.
What the? Speaking of path too big.
Yeah.
Too big, rather.
So we still have some outstanding issues that we're looking into. We still have tweaks to do to the state machine, and so there are still constants at times which don't have values. This says when to set the maximum packet size, but I think we really mean when to feed this new MTU to applications we're providing with service to. And then we have a bigger issue trying to deal with inconsistent results, as we've spoken about. Okay, on our next steps, we need to update the state machine with this path too big processing and integrate the search. And maybe our ASCII art is going to get a bit too complicated. Once this is settled down, we will then come back into checking with implementations. And that involves updating the SCTP implementation. The UDP options implementation is tracking. And then I think we hope to have at least a prototype in one of the quick implementations for Montreal. And as Gary said, we're very interested in people's experience with weird networks and weird MTUs and when things get really strange in their networks. Yeah. Thank you.
Michael, let me exercise a chair's override before you ask your question, because Tom just mentioned something interesting, being prototyped and quick. And so I'm looking at Lars and Spencer right next to the mic and wondering if one of them would like to go to the mic to have a Socratic dialogue about how this work ought to relate to quick.
Okay. Spencer Dawkins speaking as responsible email AD for quick. I think I just sent too many emails to Lars and he's trying to read them.
Right.
If Lars is not going to get up and say that early quick is probably going to pick a number and not try to do anything fancier than that, I will be interested to hear him say that. But having said what I think Lars is going to say, I do hope we can make some progress on this because, I mean, it does matter, and when we try to advance IPv6 to full internet standard, this is what broke. This is the one where we did the IETF last call and people came back and said, path MTU discovery using ICMP. Yeah, I'll get right on it. So I mean, this is broken. We can, we didn't break it, but anything that we can do to make path MTU discovery work better without having to go find Kathleen Moriarty and squeeze her unicorn that she got last night at plenary, it seems like a good thing to me. And I'll stop talking.
Yeah, I wonder too what I will say. At the last Eckert, at the moment, most of the quick implementations do something very simple, right? Just basically, you try to send a packet over a larger size, and if that works, you declare victory and move on. And that's okay. It's not great, but it's okay. The other, so having a functional and better PathMTU scheme is not necessarily something we need to ship with the very first version of Quick. It would obviously be nice, right? But it's not sort of blocking us from doing so because we can quickly rev. That said, right, I currently, so I haven't read the draft, right, because of other things to do this week, but I don't have a good feeling how complicated these schemes would be, right? If we're talking about something that is, a paragraph of text, I'm pretty sure that many implementations will probably try to put it in for V1. If it's something that is, more transporty in complexity like usual, maybe not. But we can do this later, right? Okay. So in my mind, and this is sort of not with the chair hat on, but I see us, after we do V1, I see us actually work on two things. We're going to probably do a V1.1 that is just bug fixes and little things like maybe this one, and V2, which probably has multipath and some other more heavyweight stuff. And so if this doesn't go into V1, it might realistically go into V1.1.
So, speaking as a chair rather than an author, I think it would be good if this document has very small paragraphs in about how the individual transports would implement this. It would be good if the Quick working group, or at least somebody in there, reviewed those bits to check they align. Currently, they're just pulled from the Quick spec, and that might be all that's needed. Yeah. They don't define how it works, but they say there are mechanisms in Quick which can do these things that you need. So if we can get that fixed, then we can publish this maybe by December, and then Quick can then use the algorithm later. So we just have to get a timing thing for this and at least make sure that we don't see something inconsistent, I think.
Sure. I mean, you can sort of try to get feedback on the list, right? The other thing you can do is you can just, make this an RFC, don't talk about Quick, and then you do an update or obsolete this one and do another one that includes Quick, right?
Exactly. That bit we have to sort out probably around the next IETF, I think.
Yeah. I prefer the slightly earlier discussion where Quick would likely be upwards compatible with this to come with this likely not coming in Quick V1. I put the state machine diagram up, Lars, because this is not a paragraph of text, right? It's a little more work. Okay,
Michael
what
Abrams.
did I just do here? I think I just went my way.
Are we done?
We're done anyway. Yeah. Okay.
So when do you expect to have running code?
Mm-hmm.
Tom, you didn't talk about actual code for this.
Sorry, what?
When will you have code for people to look at for this?
I have code right now, but it doesn't work. So you can look at that. If you go past my last slide, there's a pointer to our GitHub. You keep going.
Next one.
Yeah, there's a pointer to our GitHub. All of the work we're doing on this and on my later presentation is just happening in the open, so you can just go and pull it whenever you want. And I'll be very receptive to people who actually want to look at code over email.
Michael Abrams. So as someone who's tried to run jumbo frames over a lot of different networks and trying to actually get this to work, my conclusion is we need PMTUD for everything. All the applications need to do this. That's just the way it is. Operators should build networks that work and send PTBs, but they don't always. So all applications need to do PMTUD. Should be a generic, recommendation. If you turn this on, the Linux kernel, and as far as I know, the Windows kernel has a variable where you can turn on this for TCP. It's not shipped by default. I have no idea why. Right. But if I turn that on, even if my network equipment is wrongly configured or something put in something that was not properly configured, TCP still works. We need to do this for everything. So I'm extremely supportive if this helps application programmers to get that done. Is there an overall recommendation we can put out to make sure that this is now the best common practice, that all protocols should do PM2D?
We're going to need a lot more running code experience before the IESG will take a BCP request seriously, but it is plausible.
So can't we show there is enough breakage out there that where this doesn't work, that is actually the way you should do it?
Enough experience that this actually does something qualitatively useful, so that the best and the current parts of best current practice are actually correct.
Okay, so I'm not saying this is the best common practice. I'm saying to do PM2D of some kind is best common practice.
I think that's very clearly hinted at in the IPv6 documents now. The latest version of those kind of says it, but in the absence of this existing, it was hard to actually make that best current practice.
Okay, so why do we still have operating systems shipping today with the TCP black hole detect turned off?
Well, there you go. Maybe this will be more fun than we ever thought. Please keep saying that. Please help us to figure out whether it's good.
So I can speak to the PLPM2D for TCP at least. It doesn't work. It's not well implemented right now. So
Okay.
FreeBSD ships with it off because there are issues, and there's been a thread about this on the FreeBSD transport list in the last week. But there are problems with the implementation.
Right. Oh, and one more thing. When this fails and it starts going down in MTU, I want telemetry to know that it happens. A logging or a cache or whatever. So, something that can tell me that there is a generic problem.
A netstat counter.
Huh?
Like a netstat counter. Netstat counter? Like something, yeah.
So I need, so when someone is calling me, my customer help desk, they should have some information to say that this is kicking in all the time, and that's why my internet is slow.
Okay, thanks.
Spencer Dawkins, because the ISG was invoked and you're sitting in the room with 2/15ths of it, so you get a clue at least. The problem that I would have taking stuff like this forward, the BCP thing forward right now is it's really easy to say, it barely works. So I think that the work that y'all are doing to make it work better and to make it work for people who don't have it now, I think, and I'm talking about for UDP, right? I think that's great. I think you're right about the, more running code and more experience, and I hope you're very wrong about more fun than you think, because I have to do the AD evaluations.
Eric Niger-Nakama, I think I agree that we probably need to get some more experience in things that are actually working, but I think there's a risk that if we don't get get to a state where we can have a BCP at some point in the near future that here's what is good, we're going to end up with some really bad states. Like if you look at on the IPv6 side, I don't know if best is the right term for it, but the very common practice among a number of large operators is just clamp the TCP MSS to something low enough that they don't run into problems. And even then they still run into problems when that breaks. And I think there's a risk and like to Michael's point, I think if we don't do something there, getting to jumbo frames is never gonna happen, or we won't have a path there. So I think it's key to kind of figure out how do we get to a BCP. And even the Linux black hole detector implementation as of a year ago, I haven't looked recently, was also really busted in a bunch of ways, where its behavior when it kicked in was not well designed and could use a bunch of improvements, and treated IPv4 and IPv6 the same in ways that didn't make sense.
Michael Tuxen, one comment again regarding the question, why isn't this used for TCP? For TCP, if you send probe packets, you probe with user data, so you are taking the risk that your probe packet is being dropped and you have to retransmit this. And this is not only a problem that you have to retransmit this data, but also these retransmissions might affect the congestion control. And this is where Matt's document talks about if you have a packet loss, figuring out if it's related to a packet to big message, then it's not a congestion event or doing it wrong. So or if it's not, then not doing this congestion control stuff. So that's much more complex than doing this, where we have the assumption that we don't probe with user data and we don't have to congestion control. We are not impacting with the probe packets, the congestion control.
Michael Ramsden again. So I think I actually am more interested in the black hole detect so that it goes down in packet size when it detects that I'm not getting the packets through. Optimizing it and bringing it up is actually less of interest. It's great if it works, but I'm more interested in making it work and logging the event of, okay, I now lowered the path M2 by doing PM2DD. And I want all my applications to do this. So thinking of this with the probe packets and so on, yes, I agree. I don't want to give the customer a worse experience by doing larger probe packets, failing, and that causing the transmission window and so on to go down. But I do want black hole detect.
Okay, thank you very much. Bob, part 1 of 2. And we're going to need to get through each of these in no more than 10 minutes.
Yep. Okay. Right. This one recently updated on propagating ECN across an IP headers separated by a shim. The executive summary is that this draft is finished as far as the editor is concerned, both in terms of socialization around all the areas it refers to and the content. So ready for a working group last call. And that also means the other one that's been waiting for it is ready to go. And I've updated that. That's the ECN encapsulation guidelines. Top one's a proposed standard. The second one's best current practice intended. And the idea is to take them both to the IESG together. Right. Let's just quickly explain what this draft is for those who maybe are new to the room. There was an RFC 6040 on tunneling of ECN, but it had two problems. First, it omitted any mention of shims, and they have their own interesting characteristics. A shim is, as shown there, it's something that when it's on the outer, you wouldn't be able to forward it. It's not enough to forward on its own. And you also get them with layer 2 headers stuck between, usually 2 IP headers, but sometimes something else that you don't know what's inside. So that was one thing we just needed to explain what happens in those cases and add to RFC 6040. The other one is that in RFC 6040, and this is the one that David's a lot more concerned about, if the decapsulator was a non-ECN decapsulator, or you didn't know when you were at the ingress whether it was, then the idea was that you must zero the ECN outer, because otherwise, when you get to the decapsulator, if you've had an ECN mark, it might just get dropped on the floor, and then, as it shows here, all hell breaks loose. The trouble is, the reason why we didn't put this in RFC 6040 is it would make a large number of existing implementations invalid just at the stroke of a RFC editor pressing a button. And so we sort of failed to take a position, but thinking about it, what we now do is not make the implementers responsible for that, but at least make the operators responsible for configuring their ingress, if they can, by saying those words there. If it does not or might not propagate ECN, if possible, and that means they've got to get out if the vendor hasn't allowed them to configure it. The operator must configure the ingress to zero the outer, right? And David says when he reviews this, he's going to make sure that that is always the case on every case. Right. So that's sort of top level. But then when you look at what this affects, there's all these outputs of mostly the interior, some of the routing area over the years that are, and this is just a selection that are widely deployed. And so, been through this before, but the main, I'm sorry, I'm pressing the wrong button. I meant to press the red thing. There's a couple we've added this time. All the previous ones, there's the couple. We've written text into here that updates all these RFCs. So this is why this has to be a proposed standard, because it's updating other proposed standards. So we're updating a load of interior proposed standards all in one go, which they're going to thank us for. And the ones that it doesn't update, I'm going to come to on the next slide, is mobile IP, either proxy mobile IP or MIT4 or MIT6. And the last one here, the network service header, which is recent output of the service function chaining working group. And in that case, we're not updating it because we're doing a new draft for that one only. Let me explain. So there's all the RFCs we're updating, copied from the updates header. The exceptions, proxy or just mobile IP, the main reason we dropped that, it would have been nice to finish that, because then the whole scope of everything, it would have covered everything, we believe, but just the attempt to co-opt the expertise necessary past the cutoff. I had a volunteer, but then he just kept saying, yeah, I'm really keen to do this, but didn't get round to it. So I thought, we just can't wait any longer. Let's just go. So that's just left in the draft as this would be advised as to how you do it, but we haven't done it. The network services header, this is a bit of a sorry tale. I actually noticed this was coming along and approached the authors of the architecture RFC for the service function chaining working group. And they said, well, we're not doing the header yet. This is cross-layer. It's not part of the architecture. I said, well, cross-layer is very much architectural, but anyway, it now turns out that they've published the shim header as an RFC, and they omitted ECN support. So after all this effort, we've now got another one that hasn't got ECN support in it. So Donald Eastlake has prepared a draft, and I've co-authored it with him to fix that. Now, the problem is when you add ECN after it's already been there without ECN, you've then got to deal with all the incremental deployment problems of, what about cases where one decapsulator doesn't support it and the ingress does and all the rest of it. But what we're going to do is we're just going to write into this one that because this is something that is likely to be a single operator setting up a service function chaining domain, we will just say that the operator is responsible for making sure all the nodes around the edges are support this if they want to support ECN.
And I've got the next one. A quick check whether it's on your radar screen. NVO3 now has adopted a data plane and cap. It's called Geneve.
That's on there. That's right.
Okay. If Geneve is covered, you're good, because and the good news here is that it's likely to displace VXLAN over time.
Yeah.
Okay, good.
And in fact, the reason VXLAN GPE is across against it is because Alio Atlas, the routing area AD, said they're not allowing that one to go forward. So there's no need to worry about it.
In an IETF context.
In an
Can I ask a
IETF
question
context.
on that slide?
Yep. No.
Tom Herbert. So you reviewed all of these and looked at the ECN handling. Are any of these like the prototypical, that's the right way to do it, so we can just kind of copy that?
They're all got their own little foibles.
right?
Okay, thank you.
But there's a the other draft that this comes along with this, the ECN encapsulation guidelines, gives you general guidelines on how to do it and different examples and ways to do it.
Okay, so this would be relevant. For instance, we're doing trying to get generic UDP encapsulation beyond.
Tom, you've got it. You're on the second line. You've got an A-OK check.
Excuse me.
Second line, the chart. You've got an A-OK check.
Oh.
You mean the GU there? Yeah, GU's all right.
That was the one.
I mean, yeah, GU. You just refer to RFC 6040. If you do it, the main thing is if you do it when you first design it, it's easy. Yeah, it's all the incremental deployment that's the problem. If you don't do it right at the start,
we need to get through this very quickly here. Yeah,
Bill.
Philip Eardley, on the service function chaining, I think you just said the solution is that it's all within a domain or within an operator, so you're happy. In the comms BOF earlier, they were talking about this stuff, and inter-domain seemed to be very much in the focus of that. So that somehow that should be thought about somewhere.
Okay. Well, the other reason we said let's just make this a management problem is that with service function chaining, most of your functions are virtualized. It's easier to update things. So, that if that's a problem, if that's not how it's going to go, but I mean, if this is a BOF, that means it's not yet happened. So it's.
And we've got a new draft to pick it up. Okay, we need to try to finish this with this one fairly quickly.
And my personal view is that NFV as a whole is an intra-operator thing. So any aspirations otherwise are aspirations. Right. So the 6040 update shim we reckon is complete. Or I reckon is complete. The guidelines for adding ECN to protocols that encapsulate IP, which I just mentioned to Tom, it's for encapsulating non-IP protocols at layer 2. Intended status best current practice, that's also complete. I've just updated it to be consistent with the other one for all the changes. So both ready. Go. Right.
Okay, done. Good. All righty. Let's go get them.
I was standing on.
We'll worry about that at last call, I think. Let's go see about. Here we go. L4S.
Right. Thank you. Right. This is about 3 drafts, and it actually switches to a 4th draft halfway through, and then back to these all 4 together. So for those that don't know what L4S stands for, it's low latency, low loss, scalable throughput. A potential new internet service that a number of people are experimenting with next. Oh, I can do next, can't I? It's gives you extremely low queuing delay for all internet traffic. You're talking about 1 or 2 orders of magnitude better than state of the art, so about 500 microsecond across a public internet path of queuing delay. There's the architecture. I'm not going to dwell on that because of time, but essentially it involves changing the hosts, the sender algorithm in the host, using a new protocol. In other words, the ECD1 code point in the ECN field of the IP header, and using a dual queue. And the idea of it is that each element of it can be deployed independently. So you've got incremental deployment, even though you've got to deploy a number of parts. Obviously, the protocol isn't actually a part. It's sent by the host and read by the network. So just when we had the BOF on this, we decided not to set up a new working group. So I always just give a status update of all the different parts in TSV, even though some of the parts aren't in TSVWG. And first of all, so there's the second slide is about standards. First is about code and implementations. And in red are the things that have changed since last time. The Linux open source code, we're currently updating it because it's if you use the code as it is, it's probably fine as long as you use the recommended values, but we realize there's problems with the scaling if you change the sampling time of the Pi AQM.
And that's probably going to end up in an erratum to the PIE AQM as well, because we've worked out that was doing it wrong. And possibly the DOCSIS PIE one as well. That's a complementary RFC. The implementations, I guess the thing to most talk about is NS3 is there's a complete implementation in that now. It's still internal, but it's evolving. So we're aiming to release it June 18 timeframe with the whole system in it, which should be useful for people. Then moving on to the standards side of things, in the IETF, we've updated nearly all, every one of those drafts is updated, aren't they? I'm going to talk about the dual queue update, so there's been 2 this time. And the other one, there's a new draft on the interaction between L4S and diffserv, which I'm not going to talk about. And I've updated the first 2 second level bullets in that have been updated to be consistent with the new stuff about diffserv, with some other loads of it says minor. There's a lot of updates, but they're not technical updates as such. Apart from the 2 I'm going to talk about. As you know, David just said that the enabling RFC standards track 1 has been published as an RFC. Accurate ECN is pretty much going to working group last call pending reviews. I wasn't quite sure what happened in TCPM about that at the end. There's a measurement paper being published on the other one in IEEE Communications Magazine, and the Trill ECN support, which is mainly being done for L4S, is now in the RFC editors queue. And there was a talk on Quick ECN in Quick. That's also likely to decision to go into release 1, V1 of Quick. So that's status of L4S. I said I'd talk about the dual queue. I'll jump straight to the 3rd bullet because the overload handling was just explanation. We put in some terminology because the implementers that are working on it are sort of probing into the various variables inside it, and we didn't have terminology for those, so we were talking past each other when we were trying to describe what we were doing. The other main thing is started to put in more specific text on flexibility for classifiers, not only ECT1, which is the primary one, but some possibilities for addressing protocols or DSCP in a sort of operator-specific way, which is what I'm just about to talk about. Well, at least the diffserv part of it.
Okay.
And please go and read the drafts.
Will do. Please go through this one quickly if you can.
Yep. Right. So this is a new. So you see it's an individual draft still. It's the first individual draft, and you might ask, well, why do we have to talk about an AQM and diffserv together? Because the other AQMs didn't do that, and it's mainly because there's 2 queues here. We're already using a classifier, and you need to know what order you do things in with other classifiers and what the point of it all is. So the main thing is that diffserv controls bandwidth, and by virtue of that, it can control latency in some cases. The L4S architecture is purely about latency, and it deliberately does nothing about bandwidth. But then you can add ways of controlling bandwidth, one of which being diffserv around the outside of it if you want to. But it sort of decouples the 2 rather than forcing one to be done because you want to do the other. So you can think of it that it's like 2 queues as far as latency is concerned, but only 1 as far as bandwidth is concerned. And what this draft, essentially, the structure of it is that there are 4 types of interaction with L4S. The main one is none. There's 4 types of interaction between L4S and diffserv. The main one is that quite often, certainly in public internet, there is only one diffserv PHB. The default best effort. And so the interaction is none, and that's important because the whole point of L4S was to give you a low latency service for everything, and then you wouldn't need any more diff-serve complexity. There's also stuff about if you are in that none case, but you're seeing other diff-serve code points, how you map them to one or the other queues, which is on the next slide. Then there's a load of stuff, really nice ASCII art in this draft, two examples of which are here. That's not ASCII art, by the way. That's Impress. But there's essentially some examples of how you might do interesting possible services where you do want to allocate some bandwidth as well as have some low latency. Like in the left-hand case, there's a virtual reality application that might want specific bandwidth allocated to it, as well as your low latency service from L4S. And the other one is a sort of bandwidth weighted assured forwarding type thing inside the low latency queue. And the draft talks about those, so I'm not going to go into them now. So this table is in the draft.
And we're not going through it now.
No, we're not going through it now. Well, actually, every column except the most right-hand one is just a copy out of the RFC 4594, except it's updated for other drafts.
Next slide.
Now, I am going through the right-hand column, which is essentially saying we reckon it would be quite safe if you are just doing a dual queue with L4S and Classic, and you're not, as an operator, supporting any other per hop behaviors, you could put, keep pressing the wrong button, you could put EF, voice admit, and CS5, that's application signaling, into the LQ. And if any of the others have ECT1 on them, you could put them in there as well, because they're essentially saying, we are nice traffic, right? And then there's verse notes there about that. So just let you go and read that and comment on that, but just a heads up that it's there. So here we go. AQM dual queue coupled. We're getting more evaluations of it for other links than DSL, which is what it started on. That's DOCSIS, LTE, 5G, data center, either using NS3, the Linux implementation, or prototype hardware implementations. And the architecture and ID draft are sort of in a holding pattern waiting for everything else, but they have been updated. Prague, TCP Prague, there's a number of parts being pulled together. Next time round, there'll be more on queuing, the dual queue coupled. They'll be adding policing stuff, hopefully. And please review the DiffServ one. What I want to ask the chairs on that one, though, is that I don't want that one to hold up everything else, because it's sort of more informational. It's about how this works with DiffServ, whereas the other ones are more specifying how L4S works.
Bob, you're out of time. Don't ask us anything.
Well, that is the last line of the last slide.
Okay, can we ask for questions on Bob's talk? Has anybody been reading these drafts? Does anyone have any comments on this work or anything they want to ask Bob? That's 3 questions, but does anyone want to come to the mic and talk about this?
Seeing nobody, I think the right thing to do is to take the adoption question in Montreal.
Yep. Yeah, I expected that. Okay.
Thank you, Bob.
Okay. Paul? So while Paul's going up here, let me quickly explain the context here. This is work that has been proposed in IEEE 802.1 I see Pat sitting there who's going to revise some of my remarks for me if I get this wrong. In rough IETF analogy it's about the stage that a chunk of IETF work would be when you had a good first BOF, but you need a second one to crisp it up and write the working group charter. And so there is interest in 802.1, but it's not work that they've adopted and committed to doing.
Yeah, that's correct. Thanks.
Okay.
Yeah, so as David said, this is a proposed project in 802.1. The belief is that there would be a lot of interest here in the group, so that's why we're sharing that. We agreed back in November to create what we call a project authorization request, which is how we begin a standard there. The motivation for this is described in a report that is available at that link. It's an output from an industry connections activity that the IEEE is also doing, where it's sort of pre-standardization activity. I talked about that at the hot RFC. Yeah, so the status is that we decided to delay approving this project until we got further feedback and input and sort of improve some of the simulation data as well. So that's why I'm here to do that. And the hope is that we would revisit this in July. That's when we would create that. So what are we talking about? Congestion isolation is an amendment to 802.1q. So if you guys are familiar with 802 standards, that's kind of the book, if you will. We would be adding a chapter here. And the scope of this is specifically around identifying congested flows in a data center environment. So not really intended to go across the wide area, sort of specifically for high performance computing, kind of RoCE V2, distributed storage environments, or, AI kind of environments. And so the idea fundamentally is that the switches, which are now basically routers, would be identifying flows that are causing congestion, and they would be adjusting the scheduling, the transmission scheduling of those flows. And then they would be signaling to their nearest upstream neighbor to let them know the same thing. And we'll see kind of what that does. The goal is to eliminate or reduce head-of-line blocking that those congestion flows are creating, kind of to do some automatic separation, if you will, of mice and elephants, or assuming the elephants might be the ones that are causing that. And what's important here is that this is intended to work in conjunction with the end-to-end congestion control that we define here in IETF. So assumptions in the environment, that data center, these kind of high performance data centers are
sorry,
yeah,
can we go back one slide?
Sure.
The bridges, aka L3 switches, is there an aka router?
Yeah, that's what I was just about to show you, was our assumption about how people are building these high performance data centers. So yeah, these are basically routed links, right? Everything is a switch, but yet it's doing the layer 3 forwarding. A lot of commercial silicon being used to do this. So that's primarily an L3 class network. We are using ECN to try to get those sources to adapt their rate to eliminate congestion. And that, the control loop obviously can be protocol specific if you're UDP based. And if you really want a lossless environment where I don't drop a packet, because some protocols are not tolerant of that, there's still potentially the use for per priority or priority-based flow control. Now, a lot of people don't like that because it has issues. But if you really don't want to drop a packet, that's still kind of one of the options, or the option to kind of keep in place there. Typically now, as we're saying, these are all routed links. So we're not necessarily using VLAN tags. We may be, but we're using DSCP code points to indicate things. So this is not a big layer 2 fabric. So 802 already has some congestion management tools, as I mentioned, per priority or priority-based flow control. So in our standards, we have 8 classes of service. You can enable flow control on a per class basis. So if you want to create a lossless class, you turn that on. When the congestion occurs and a egress queue is filling up or an ingress queue is filling up, you would push back to your upstream neighbor with a pause that blocks all traffic in that traffic class. And some of the downsides of that, of course, is that there may be other traffic in that class that is going somewhere else, and we're now blocking it. And if that pause remains on for a long time, it spreads and creates a problem of congestion spreading, which causes buffers to bloat, latency to be very, all over the map. So a lot of people don't like this. A lot of people turn it off in the middle of the network, specifically because of these problems. There's some discussion about maybe you still have it on at the very edge with the server because of different matching of buffer sizes and things. The other tool that 802.1 has is a thing called congestion notification. Now, this was built a while ago specifically for the layer 2 fabric. So this picture, imagine it being an all layer 2 network, and we needed to do something to support non-IP protocols like fiber channel over Ethernet or Rocky version 1. They didn't tolerate loss very well, so we wanted to create a layer 2 lossless environment. And in this solution, there's a congestion's detected and a message is sent across the layer 2 fabric to the source, and a rate adapter, a reaction point would be perhaps on the NIC, who slows down the traffic to avoid the congestion. Didn't necessarily get a lot of deployment in the real world, a lot of complexity. People didn't like that one either. So what we're trying to propose here is congestion isolation. So what again is it? It's working in conjunction with the layer 4 or end-to-end congestion control. The goal is to try to build these data centers bigger and faster, and to support lossless transfers as needed, but in a way that's not so impacting, or that priority flow control has. We want to do this sort of agnostic of the types of flows they are. And one thing that's very obvious, as we go to faster links like 100 gigabit Ethernet, the amount of buffer per port per gigabit is really been dropping. So, there's a lot of pressure on keeping small buffers but again, that exacerbates the problem of loss here. So we really want to reduce the frequency of using that per priority flow control or needing to use it at all, and really eliminate headline blocking. So again, just quick summary, it's you identify the flow. When you identify the flow that's causing congestion, you reschedule it to a different traffic class. And we want to do that in a way that doesn't create an ordering issue, although there's been a lot of discussion about maybe ordering isn't quite as bad as it used to be. And then we want to signal our upstream neighbor so that that neighbor can do the same and eliminate the head-of-line blocking that's caused by pausing the traffic class. So and we saw this picture before. When we don't have this solution in place, if I send pause to a traffic class upstream switch, a blue flow here that might be going somewhere else around the congestion gets blocked as well. So that's the head-of-line blocking we're trying to eliminate. So when we detect the red flow here that's causing congestion, the idea is to move it into a different traffic class, schedule it differently, signal our neighbor to do the same. He'll move it, and that frees the traffic class for the non-congested flows. So that's at the highest level the mechanism. So in a little more detail, we would again be, quote, identifying the flow that causes congestion. Well, most routers, switches have means of doing that today. When we're marking ECN bits, we do it either probabilistically or in some method we're identifying the flow that is causing the congestion. At that point, we want to subsequent packets that come into the downstream switch, we would want to put in a different egress queue. And now that queue would be scheduled differently, perhaps a different priority, perhaps with a new technique that would eliminate out of order scenarios. Eventually, if that congestion persists, we may hit a threshold on that queue, and then we would signal to our neighbor, hey, this flow is causing a problem. Let's tell the upstream neighbor to do the same. And the objective now is that upstream neighbor will be scheduling subsequent packets in this other traffic class. We've eliminated head-of-line blocking. If the congestion continues to persist, we might, if we want to be lossless, we might issue a priority pause. But now we're pausing only the congested queue. So the goal here is that we're again leaving the non-congested queue without being blocked. So that in a nutshell, that's kind of the details. There's a lot of subtleties about it. We're happy to talk about it. We've done some simulation. There's a need to do more simulation. All the detail is available here on these links. The way we did this was setting up a kind of a two-tier class network. We used sort of a Rocky V2 traffic model, and we sort of organized the randomness of the servers talking to one another in two factors. One, we created persistent incast with a set of traffic, and then the other servers we just do many-to-many traffic, and we would select flows that match this distribution. And so what we also modeled a couple different approaches. One, the one that we're proposing in the project, which is just a having a single congested queue monitoring a non-congested queue, but there are implementations that have already been doing, say, mice and elephant separation on the front end where they may already have that. So we also modeled, what if we add that congestion isolation to that environment as well? So we had both of those, and so the results here, I'm just giving you a little snapshot. The details are in the paper. But in general, what we saw was when we're trying to use a lossless environment, and we are still using per priority pause, on average, we were reducing flow completion times by 38%. It had a dramatic impact on the mice or the small flows. So we were reducing flow completion time by 63%. And when we used the 3Q model, having already separated mice and elephant, it had less of an impact because that alone is a useful feature. But we still saw on average a 25% gain in flow completion time. Now the loss-E scenario, or the one that tends to be deployed a little bit more, where we're not using priority-based flow control, what we looked at here was, well, how do we reduce packet loss in general? And we looked at two different scenarios here. One was where I don't tell my upstream neighbor about the congestion. I just do local rescheduling for that flow. That had about a 26% gain over just pure ECN tech mechanism. But if we do signal to our upstream neighbor, we're effectively adding more buffering, to these to allow these flows to be delayed while the ECN control loop catches up, and we saw a larger savings in packet loss. So because of that reduction in packet loss, you get better throughput, you get lower latency, a number of obviously beneficial factors. We looked at how long, if you are using PFC, how much are we reducing the use of it? So, because we know it's kind of has bad implications, but it's still your last gasp effort in order to not drop a packet. But what we've done is reduce the frequency of seeing those packets significantly. So the impact is much smaller, and the amount of time that they're paused has also been reduced as well. Yeah.
Michael Urban's again. How fast is this X on, X off transition? And how often can you do that? Can you do that millions of times per second, or how often do you do that?
Yeah, I mean, you can do that fairly frequently. I mean, it's propagation time between the two nodes, and it's based on thresholds that you typically set on the queues that will not have it.
But the hardware would support me sending back to back for 1 microsecond, X off, X on.
Well, yeah, I mean, the frequency of receiving them, I don't think is an issue for the hardware to react.
I mean, the
to
duration. If I'm setting an X off and I wait 1 microsecond and I turn X on again, the receiver will pause for 1 microsecond and then resume again.
Well, you're gonna have a packet's worth of data that you're pausing as well, right? You're not stopping. You're not preempting.
I understand propagation and so on. It'll take a while for him to react.
Right.
But if I'm just flipping this, will he stop for 1 microsecond? And then resume again.
He would stop for, no, there's a quantum in there that he stops for. There's a minute, I don't remember off the top of my head what the number is. Pat can probably correct us on this. But there's a quantum and then it would stop for a packet duration.
So when he receives it, he might already be transmitting a packet.
Right.
So if you send it too close together, he might get the X off while he's sending a packet and then get the X on before he stopped, so it might have no effect at all. Generally, the way there's a time quantum in there, and that's partly to protect in case the X on gets lost. So most of the implementations I know of set the time quantum to maximum and count on that they will send it on when they an X on when they want it to go back on. So generally, they have a buffer fill level where if the buffer gets up to this threshold, to the high water mark, they send the X off. And then when it gets down to a low water mark, they send the X on so that hopefully the buffer doesn't empty before things start coming in. So they keep throughput up.
Mike, if it helps, the answer to the question you might be trying to ask is this sucker, X on, X off, and PFC are implemented in very low-level hardware, very close to the port.
Right. So my point here is that 100 gig, 1 microsecond is 10 packets, 1500 bytes packets approximately. if I tell it for 1 microsecond to pause, if I got the, raised to the 10 here, correct, at 100 gig, I'm asking him to pause for the equivalent duration of 10, 1500 bytes packets. Is this actually feasible, or am I off by magnitude?
Yeah, as David mentioned, I mean, these are all implemented in the Mac chip itself. It's all hardware.
I mean, if that guy has a shared 12 megabyte buffer for the entire thing, 10 packets here is actually, it's a non-trivial part of the buffer.
Right, and you have to calculate that headroom. You have to, if you're trying to be purely lossless, you have to reserve
but
that memory.
it is on microsecond scale and not millisecond scale anyway.
Oh, yeah. Absolutely.
Except I don't know anybody that uses it on that short a scale. I mean, that's not the way it's generally deployed.
Okay.
What, like as Pat mentioned, the way it's deployed typically is you send an X off for a maximum amount of time, and then when you hit a threshold of availability in your headroom, you send an X. You cancel it effectively. Yeah.
All right, Bob Briscoe. First of all, what's the trust model? Are you assuming this is sort of multi-tenant cloud, or is it? What is it?
It's assumed to be all under a single administrative domain data center. Somebody's managing a data center. It could be a cloud, or there's overlay networking running, but a single operator managing the infrastructure.
Okay. So
one landlord, there is a God.
Yeah, but there's a God, but there's a lot of sort of Satan's helpers in the in the potential in cloud, in virtual machines or whatever. Yeah. So have you considered virtual queues instead of PFC, or either to complement, give you a bit more time for the
just to make sure we're trying to eliminate or not use PFC at all, right?
Yeah.
So so we have talked about the ability to do, say, hierarchical queues or things like this that are sort of we wouldn't necessarily standardize, be kind of implementation specific. So that has been discussed.
But by virtual queues, I mean what we called here pre-congestion notification years ago, which is where you can notify congestion before before the link is actually buffering.
Yeah, no,
that gives you more headroom. So you can start slowing down the other end before you've actually got to the. So we can talk about that.
Talk about that.
Talk about this. This is a different design.
Yeah.
No, but I mean, that would mean you wouldn't have to use PFC because you've got enough time to stop the source sending. Yeah.
Right.
Yeah. Yeah, but a virtual queue slows you down before you're starting to buffer.
Yeah.
If these are I don't know, Broadcom switches, Cisco switches, they have virtual queue in their hardware already.
Okay, next.
Yeah.
So both of your questions, right? So we actually do have this, and it's not 1500 byte packets. It's usually like 2000 byte packets. I'm so many from Oracle. So we actually use like 2000 byte packets or 4000 byte packets. So, and yes, the buffering is a pain, and yes, we don't like PFC. But we also are trying ECN, and we have PFC at the edge, not at the core. And ECN mostly works except like for the initial burst. So the key to this is that, if the end-to-end ECN works, you won't need this. This is only in addition to the ECN.
Correct. That it's in support of ECN, right? And so the idea is that we're providing, let me go back to this picture. We're trying to provide enough time for that control loop to do its thing. So the assertion is that as we get to faster and larger, more data centers, there can be potentially more data in flight. The buffer sizes are not keeping up with that performance. So we want to make ECN be more responsive in those kind of environments. And so what we're doing is using effectively the switch buffering for the flows that need it, that are causing congestion, to give time for ECN to kick in. So that's the fundamental high-level objective here.
And that's also some of why I've been an advocate for having Paul come and present here, because he's got two interacting control loops. When that buffer starts to back up, you're going to get pushback with congestion isolation as opposed to priority flow control first, and that's going to eat switch resources. And you're going to spend switch resources on that link level pushback until the ECN control loop kicks in and reduces the overload, at which point you can recover switch resources. And interacting control loops are no end of fun, and that's something that I think this group could take a look at and perhaps have some helpful input to Paul on. Because it's going to be the corner cases where it doesn't quite work all that neat, clean, and clever, where weird stuff's going to happen.
Mia Kuhleman, maybe I missed that part simply, but so congestion comes up if like multiple flows share the same queue and the load is higher than what the link can cover, right? So how do you decide which one is the bad guy?
Using the similar techniques that you would be using to mark the packets with the ECM bits in the forward direction. So something on the order. We have a specified mechanism in our congestion notification. It's kind of like a sampling, kind of random. It is possible that you might pick the wrong flow, probabilistically, but the expectation is we're using the same mechanisms that that are specified or routers are using to set ECM bits.
So you say random, basically.
Yeah. So effectively, you're monitoring the egress queue depth, and you know that I'm filling up, and so then you're going to be sampling, or you're going to be taking the flows that are occupying that. It could be an implementation detail on how you choose.
So if you have, for example, only end-to-end congestion controlled flows, they will always try to fill the bottleneck link.
Correct.
So even if you take one away, they will try to fill it again. So it actually just helps you if you either take a flow away that really is on a constant bit rate that is higher than the link capacity, or if you can take all the adaptive flows away and you only have like constant bit rate flows that are below the link capacity. Otherwise, you will still have congestion.
Yeah, I mean, the expectation is eventually they're going to be adapting their rate, right? And so we would take more than one away. Potentially, we're moving multiple flows. However, we're recognizing congestion in the egress queue.
So, okay, what I actually want to say is that the congestion is not, there's two kinds of congestion. And one is simply just the feedback signal for the congestion controller. So the goal of the congestion controller is to drive congestion to get a signal to understand where to adapt.
Mm-hmm.
So as long as your congestion is not, going higher and higher up over and over again, that's like the normal operation. And I'm not sure if it makes sense to intercept there. I understand that you don't want to have loss, but that's why we try to deploy ECN, yeah.
Right. Yeah, we're really trying to eliminate as much loss as possible and still support that control loop.
So, Richard Schaffenegger, NetApp. I just was curious about how the granularity would work out. I mean, you can take a lot of bits from the headers, and would you basically stack all of the offending flows then into the same congested queue?
Yeah, you would. Well, I mean, you would you would effectively move all the flows to the congested queue. Now, the scheduling of that congested queue can be done in a way that when the congestion subsides, it's almost as though you added some buffering in the middle of the queue, right? So you could be putting all the queues that you're marking in there.
Don't get me wrong, but I believe this is good, great work, which is a huge improvement over PFC. And I would really like to see this come into fruition.
Great, thank you.
Yeah.
Okay, so I'll wrap up by just the last slide, which is the kind of call to action, if you will. So again, the next steps are continued technical review, getting feedback. We're going to try to do some additional simulation. I would love to work with anybody here that was interested or willing or has simulation environments that we could talk about how we could leverage to model this. We have our own, but you need third parties to get convincing data. I'd love to find out about how this works with other congestion control algorithms like BBR and time-based schemes as well. So we expect a motion in July to approve this project or continue to delay it based on where we're at. So how can the IETF help? So again, there's already a working relationship between the IETF and IEEE. This would be a great topic for discussion and discussion next steps there. I'm happy to contribute there if possible. You can send feedback directly to me. We also, as I mentioned, the motivation for all this work is written in a draft report that's also an open process, and we're inviting anyone to kind of participate on that, and you can find that information there. It's what I talked about in the hot RFC as well. So, all right.
Thanks, Paul. I guess you can continue to talk to Paul by seeking him out here, or you can go and get cookies and coffee, but please come back after the break.
Yeah, so we're going to start again. I think we start top of the hour, actually 10 after.
10 after, yeah.
10 after, so we've got 10 minutes. All right, cool.